Hey guys, how's it going? My name is Mark, and welcome to the Pixel Nuts Twitch channel. Today I'm going to be doing some programming, which you may or may not have seen before. Let me just fix my camera here. I guess I never fixed it from before, so I'll just quickly fix that. So yeah, if you guys don't know who I am, whoops. My name is Mark. I'm also known on Twitch as Fluffy in some spots, so you may know me from my Twitch channel where I do some game playing and stuff of that nature. But yeah, over on the Pixelnauts channel here, I like to do programming streams, and today we're going to be working on Rocket Rumble, which is our new game, a combat kind of racing brawler game, kind of similar to Mario Kart and Smash Bros. A little bit of DNA from both of those games kind of mixed in. And yeah, today I'll be working on a couple different things, so let's just get right into it. So, basically what I'm going to be working on today, there's two different things. We have a drafting mechanic in this game that actually I developed a while ago, but some of our newer code, I developed it probably almost 6 months ago, and some of our newer code that we've implemented into the game has actually broken it, which is what happens from time to time. Our project, it's one of those kind of things where I work with one other programmer, and then we have other people working at Pixelnauts as well, and I'm sure a lot of you guys have met them. Also, how's it going, Mystic? Thanks for stopping by. Appreciate it. Hope you're having a good day as well. But there's just two of us main programmers at Pixelnauts, and even though we're very used to working together and stuff, we got a kind of a good flow on that. But the project is just, you know, it's at the stage where we're into open beta, and it's so big. We have hundreds of scripts between the two of us, so sometimes that kind of thing just happens. You know, you add new code or you start adding online networking functionality, and stuff just breaks, and you have to kind of go back and rework it, or kind of look at how you did it and you know, refactor your code a little bit. Been an okay day. I'm glad to hear it. Yeah, sorry I didn't stream last night, but it's good. It's good to. I won't be streaming on my main channel tonight either, so I kind of get like a 2-day break. So I'm kind of happy about that, and then I'll be back on Friday with. We're gonna try Noita for the first time. That's over on twitch.tv/markgamedev if anybody's interested. But yeah, basically, I don't know. I like to think of programming as a big puzzle, and sometimes when you decide to add a new puzzle, and imagine it's a big puzzle, but you can add new puzzle sets to it that all fit together. And sometimes when you add a new puzzle on, you have to break some of the pieces out of the old one to get the new one to work, and then sometimes things end up broken. It's all good. Sweet, thank you. So we're gonna be taking a look at fixing up that draft mechanic, like I said. And the other thing I would like to do today is add on a little bit to the Bumper Stars mode that we've been working on. So if you're just joining me and you haven't been here before, on stream I have been working on a new system for the game that we're calling Bumper Stars mode, because that's what the game used to be called. So that's just what we're calling it internally. But the way the game used to work, and if you played the closed beta, you'll know this, if you run into obstacles or get hit by an item, you would die right away. And we're changing that. So we have a new system in place that's going to be in the open beta. And if you guys are interested in that, you can sign up for the open beta on Steam right now. Or wait, no, you can't. Sorry, you can't sign up yet, but you can wish list and follow our game on Steam, and you'll get an announcement when the beta signups go live. And somewhere around the end of the month, this month. So we'll have the whole new health system and everything implemented. And if you guys have joined me for some of my previous programming streams, we've been working on that. So we got stuff working, like when you run into obstacles, you bounce off, and when you get hit by items, they have different effects. And I've actually added some cool ones, which I'll show you guys here. Since last time I did a stream, I have added some new stuff. So I'd like to kind of get you guys up to speed on where I am. And yeah, then we're going to work on making... So in this game, it's all a single screen. So if you fall off the screen, you die. So we're going to work on taking that death system and bringing it up to date with the new health system so that we can test different ideas. So maybe we want it so when you fall off screen, you get bounced back up into the race, or, you know, anything like that. Or maybe we just want to leave it the way it is, but we want to make sure it's all going to work with the new health system and stuff. Yeah, so that's the other thing that we're going to be working on today. We'll probably start with that. So we'll load up the Bumper Stars testing ground that we made last time we were here. Last time we were here, we just made this little test track so that we can load into it real easy and test out our items and stuff. And I'll show you guys some of the stuff that I've been working on. So let me make sure my game volume is on here. Should be, but... oh, it's actually muted, so... Okay, so we gotta make sure that the online scene is loaded. And yeah, I'll show you guys what I have done since last time. Let me just pause my my music here, because there's in-game music, so... Oh. I just realized I left something upstairs, guys. I will be right back. All right, guys, I'm back. Sorry about that. I left my drink and stuff downstairs, so just grab that. Yeah, so here, I'll show you guys what I have in the game now. Seems like the game's a bit quiet on me here. Oh, I got an error here. In the race? Interesting. It actually didn't work and I got an error. Okay, let's just load the photon scene one more time. We'll try this one more time. Looks like it's loading a character, okay. Oh, maybe it's not. Oh, why is it doing this to me again? I don't understand. Yeah, it looks like we're getting a bad error here. Let's take a look at this. Might as well do some bug fixing here and see if we can see what's wrong. So, this is the culprit here. See, one of the cool things about Unity is that you can open up your this little error log down here, and it tells you what's going on. So, I know that these errors here are nothing of consequence, and then I can see that there's an error here with the race controller, and it's telling me I've reached maximum player count of 1. And then I can see that there's an error here. It says object reference not sent to an instance of an object. So usually what that means is that the code is trying to find an object that does not exist. So it's saying player controller, trail controller. Oh, I see. So there's no trail controller in this scene. Now, I don't necessarily know if that's an issue or not, but we'll sync the new changes and see if that makes any difference. And in the meantime, we can look over here. So we need to find... So this is all the stuff that I've changed since you guys were last here. It's quite a bit of stuff, obviously, because between, you know, between streams, I do lots of coding, obviously. I'm working on it every day. So, I created some new stuff for the obstacle types. So now we have generic obstacles that can be anything, and they just have like a generic crashing sound. And then we have insta-kill. We have a tag for insta-kill obstacles now too. So you can now just tag something in game that you want it to instantly kill the player, and it'll instantly kill the player without it kind of bypasses the health system and just kills them right away. And then we have tags for rock, metal, lava, magma, and water and crushers. We added those ones last time, but the magma one was new. And I've added into the object system the ability for it to tell the difference between that stuff and to do some unique things. So we have our handle obstacle collision here, which we had before. And now you can see that it detects the different types. So if we have like a generic obstacle, it does certain things. If we have a rock obstacle, it does certain things. It plays like a unique sound clip and stuff. And I actually created this new system of holding data called bumper obstacle data. And you can look at that real quick. So basically this is just a class that holds data, and now I can call this and send it back and forth between different scripts. So it's just called bumper obstacle data, and you can see it has like how much damage do we want it to do. It has a tag to tell it what type of obstacle it is. It has a tag for the state. It has, we can tell it how much force we want hitting the obstacle to exert on the player. We can tag it with our delay death function, which is something that we worked on last time, you guys might remember. And then we can pass in a unique audio clip, a unique visual effect. Hey, Alex, how's it going? Ah! And we can pass in unique animation data as well. So now we can differentiate all those type of obstacles that we have in the game. And I'll show you how that's working, if I can get this part to work here. So I'm just trying to get this scene to work, so I'm going to reload it. How's it going, Alex? A long time no talk, except we talked like 5 minutes ago. So now we need to load the photon scene, and hopefully our scene will work. I don't know why it wouldn't. I have Steam open, so that wouldn't be the problem. Because now that our game is tied to Steamworks, we have to have Steam open. Yeah?
Do you know where the big one cord is?
No, I don't know. You're going to have to ask Mummy.
I did, but she didn't know.
Well, I'm sorry, but I don't know where it is.
Me either.
What do you need the cord for?
So I can charge the blue controller.
Okay. I'll be right back, guys. Archie. Okay, sorry about that. Archer's just trying to charge his PlayStation controller. Viciously kidnapped by mysterious passerby. Hey, Nida, how's it going? Hope you're having a good day. Okay. So what were we doing? Oh, yes, that's right. We're going to test this scene and see if we can get it to work. It still looks like it's not working, though. I don't understand. It doesn't like to work when I'm on stream. Oh, well. It's going? Same. I was like a bit sick yesterday, but I was feeling good enough today to stream and work on some stuff. So basically, the idea behind this is now when we hit a new obstacle, I've made it so that it has unique sound effects and the capability for unique particle effects and stuff like that. So I'll play just the regular game here so you guys can get an idea of what I added exactly. Hopefully the audio is loud enough for this too. But if we load into Asteroid Field, for example, usually takes a sec to load in the editor. Oh, actually it was pretty fast that time, surprisingly. So, because we have all that obstacle data set up now, you can tag any object in the game, and you can be like, oh, this is a rock, or this is a metal object, and the script will handle all that different stuff. So basically what that equates to right now is a unique sound effect, but all the capabilities in there for us to slot in new particle effects. So like when you hit a rock, for example, it can spray out some rock particles, and it can play a different animation possibly. But right now we just have like the different sound effects. So when you hit a rock, it kind of sounds like you hit a rock. And if I find a metal object here, if you smack into a metal object, it makes like a ding. Oh, I guess those ones aren't tagged properly. Gotta find a different one. We're also having a bug right now with that, but it doesn't seem to be affecting single player, so that's good. Yeah, we can run into a metal obstacle here. I just gotta kill myself. So yeah, if I get smacked by one of these crushers, you'll hear it, I believe. Or if I run into one of them. Now I can't hit one. These are so easy to get hit by. Now when I want to hit one, I can't. Yeah, you guys could probably hear that, though. It sounds like you're getting smacked in the face with a frying pan or something. Bang! And eventually, like I said, you know, we'll have sparks maybe when you hit something metal. And, yeah, we also have a sound for magma pillars that I can't show in this level, but it kind of sounds like water hitting a pan. It's like a sound. Okay. Hopefully you guys could hear that anyway. So since we can't use the testing ground, basically, I'm going to work on it so that when you fall behind the kill screen, we'll be able to add this kind of data to that, so that when you fall behind the kill screen, maybe we could make it so it blows you forward. We could test all kinds of different things, but mainly I just want to get it hooked in with the new health system and stuff, so that we're not having any issues with conflicts between those things. So basically right now, the way it's implemented is very simple. So I just got to find it in here. Here we go. So we have a bool that says player, it's just called is off camera. So basically we're checking to see if the player is off camera. So now we need to find all the references where this has been used. So we can click that, and we can click find all references, and then we get this little screen. Whoops. We get this little window that pops up down here, and we can make it bigger so we can see what's going on. And you can see this is all the places where that bool is used. So it's used in mobile camera target, which is a different script, but here it's used 4 places in the player controller. So we want to find the spot where it's checking that and setting it as equal to true. So you see we have here is off camera is equal to, so this is where it's being set. So in the update function, we're saying if the race is going and we're saying is off camera is equal to, and we're checking if the player is off screen with this bit of code here. And then we're saying if the player is off camera, then kill the player. But this is not what we want to do anymore. We want to loop this in to our new player health system. So what we're going to do here, we're gonna create a function, and we're going to call it here just so that we don't have to worry about this for a little bit. So within our player health system script, we have a handle obstacle collision function, and we have a nice big handle item hit function. So we're going to close both those for now because we don't really need those for what we're trying to do right now. And we're going to create a third big function as part of this script. So it may not end up being big, but anyway, we're going to create a unique function for our purposes here. So we're going to create it as a public function. Now you can create either a public or a private function. If you create a private function like this visual fun times one, then if I tried to run that function from over here, by typing, like, we'll do it in here. What are we going to say? So we have a reference to player health system here. Whoops, that's not the right one. What did I call it now? What did I call the reference to the player health system? I just called it health system. So this right here is a reference to this script. So we can call functions from here. We can call, or we can set the data of different variables from here. But we can call our handle item hit function, and that'll run that function there, whatever code we have in there. But if we try to call this visual fun times function, you can see that it gives us an error, and it says, oh, that's not the right error because I need to pass stuff in. So we can pass in an audio clip, checking clip, and we can pass in the an FX trigger here. Why is it letting us run it? Oh, that's confusing. Normally you can't run private functions. I don't know why it would let us run the private function like that. It shouldn't. It would give us an error eventually when we tried to run it. Normally it should just error out right now and tell me that it's not going to want to run it. But basically if it's a private function, then you can't use it outside of the scope of the script that it's contained in. But right now, we want to create a public function so that we can call it over here. So we're going to say public void because our function doesn't need to return anything, and we're going to stick to our naming convention here. So we have handle item hit and we have handle obstacle collision. So we're going to stick to our naming conventions here, and we're going to call this handle. We'll call it handle leave screen because that's essentially what we're doing here. We're saying if the player's off screen, they're leaving the screen. Normally that kills them. So instead of running this death function, we're going to run health system dot handle leave screen. And we're going to get rid of this death function for now. Well, actually, no, we can leave it in here. So what we're going to do is we're going to check and make sure that our bumper stars mode is turned on. So we're going to say if mechanics options, which is a script I've created, dot instance dot bumper stars. Oh, that's the wrong one. Dot mechanics dot bumper stars. So we're going to say if bumper stars is turned off, then kill the player. Else, if it's turned on, then handle the player leaving the screen, which is this function here. Because I have a toggle so that you can actually turn bumper stars mode right off if you want to test the way the game was before, or if we want to create the way the game was before as another type here. So, what do we want this script here to do? This is going to be our pretty new script. Let's just isolate it a little bit here. Make the text a little bit bigger. So, handle leave screen. Handle when a player leaves the screen. Right. Oh, sorry, I missed that in chat. Hi, Logan. I hope you're still watching. I hope you're having a good day, Logan. So, what do we want to do here? Well, we're going to figure it out. We're going to open up our handy-dandy paint.net here, and we're going to figure out exactly what it is that we want to do. So, we want to probably give the option to do a couple different things, right? So, let's say that this is our screen right here. And we have our track that goes off into the distance like so. Right? And then we have some, you know, little asteroid dealies here and here. And maybe a nice big one here. And then we have a real handsome one here with a big nose. That actually, he's not that handsome. He kind of looks like Gru. And then, and then since we have Gru over here, we gotta have. Oh no, that's no good. We gotta have our minion asteroid here as well. So let's see, he's got his little arms and his little overalls, right? They wear overalls, right? How the heck do they wear overalls when they have no neck? The bands of the overalls just like go over their shoulders somehow like this. And then they have a big old mouth. They're like, ha 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 ha. I don't know. That's a bad minion. That's the worst minion anyone's ever drawn. I apologize. And they have little feet, I guess. So anyway, that's our minion asteroid. So, we'll say that we have our kitty cat, our Meow Meow. He's up here. He's racing along. He's just flying. He's racing. And then we have our... Let's see, who else do we have in this game? Oh, right. We have our big oinky boy. He's Daddy Pig. Oh, Peppa, I'm an expert at racing in space. I'm Daddy Pig. So we have Daddy Pig here, and he's big and fat. Daddy Pig, your belly is too big. I'm not. My belly's not big, Peppa. And he's over here racing. And they're just shoop-de-whooping along the track. But then we have our corgi. And he's down here with his little ear dealies. And he's falling off the track, so he's sad. He's like, oh no. And he's got he's crying a little bit. He's like, I don't want to fall off the track. Don't leave me behind. So, we need to figure out shoop-de-whoop. We need to figure out exactly what we want to do in this scenario. So, if he's falling off the track here, you know, maybe what we want to do, maybe we want this screen to kind of act like a barrier. This screen here. So maybe what we want it to do is bounce him back up here, but take away some of his health. So, you know, we could copy him here. So maybe we want it to bounce him right back up here so that he's back in the action. If we get him back in the action like that, We get him back in the action. We dry his tears. And then he's happy again. So maybe that's what we want to do. We just got to fix this here. We got to get rid of this piece of track underneath him. So he's a happy pup. Now he's back at it. He's back in the race. Boy, whoop, that's too big. My brush is too big. So maybe we want to bounce him up here, but he's gonna lose one health point if we decide to do that. So, you know, he's got a little heart here, but his heart is broken because he lost a health point. But maybe what we want to do, and I'm just... Normally he would just fall off the screen and die. So maybe we want to bounce him back up here. Maybe we want to, like, do, like, the Smash Bros. Thing and, like, fire him off in a random direction and he goes, like, bouncing off edges of the screen and then back onto the track in a random area. Or, you know, maybe it doesn't bounce him straight back onto the track. Maybe it fires him randomly in like a random arc around the track. We could do something like that. But basically, we just want to have options so that if we want to test the ability to have him not fall off the track and die, we can. So, you know, we can handle that pretty easily. And maybe we could focus on... Whoops. Maybe we could focus on getting just those few things done. So we'll have... we'll go to our trusty dusty notepad here. No, we don't want Notepad++. We want regular Elite Notepad. Okay, so we got Notepad. So, let's see. Maybe we want several options. So, fill screen options. So, maybe we want option 1 to be kill the player. Well, we already have that option done, but that's definitely option 1. And then option 2 would be to blow the player back on screen and lose a health point. And then option 3 would be to blow the player back on screen at a random angle. Oh, we forgot our hyphen. And then, just for fun, option 4, cause an explosion that sends the player flying through the air. So it could kind of almost act like a bomb. I mean, that's definitely a possibility. So there's our... We'll work on these four options here, and that should be pretty good for now. So I'm just going to move my notepad over to my other screen so I can see it. And we'll close our beautiful piece of art here, but we'll keep it. We're going to save it. So we're going to save as. And we're going to call this beautiful piece of art Mark's Masterpiece. So, now that we kind of know what we want to do. Oh, I guess I should have barked for those. Thank you guys for the sound alerts. Woo, woo. 2 barks. So, we're gonna bring our notepad stuff over into here. So, the main purpose of this function is to handle when a player leaves the screen. So, let's make that an XML comment up here. XML comments are pretty cool. Actually, I'll show you them right now real quick before we do this. So let's say that we had a couple variables in here. So if we want to do an XML comment, a regular comment is just 2 dashes, and then you can write whatever you want in there. But if you do an XML comment, sometimes it has special functionality. So say you do 3 dashes instead of 2. And see, you can add a summary, so you can write whatever the summary of this thing is. So, like we were saying, we'll copy our summary in here. handle when a player leaves the screen. And you can see that it actually gives us spots here to tell people that might want to use this function what bum1 and bum2 are. So we can write in here, bum1 is an int that denotes the size of one's bum rounded up. And bum2 is a string that lets you name your bum whatever you may desire. So we can write this stuff in, and then if somebody was to use this function, and they're writing it out, so let's say I called this function, so handle leave screen. Now this is recursion, you shouldn't do this. But you can see that it tells us our summary here. Handle when a player leaves the screen. And then as we write in these variable declarations, we can also see what we named here. So I like to use XML comments, partially because it's got that built-in functionality. So if you're calling it from another script, you don't have to come here to see what it does. You can just read it. So you can see here where I've called handle leave screen here, you can see it says handle when a player leaves the screen, and then there's an error because we haven't put in bum1 and bum2. But we don't actually need those, so we'll get rid of those. But I like to do XML commenting because it kind of makes it so that you don't have to do a lot of comments all throughout your code. So if somebody else is reading it, it just makes it very clear what it's intended to do. So we're going to put some comments here based on what we talked about here. So we're going to have option 1, kill the player, and we're going to have option 2, blow the player back on screen, and we're going to have option 3, eject the player in a random or at a random angle back onto the screen. And then we're going to have option 4, which we talked about, causes an explosion that sends the player flying. And that we could have that affect other players too. Affects other players. So maybe when they hit the bottom of the screen, they explode and they go flying. But if there's anybody nearby to that spot where they hit the bottom of the screen, they could also be affected by that explosion. That's just something for fun that we can try out anyway. Okay, so now we have to write the actual function. So we want to allow for these different options here, and we're not actually gonna we're gonna write this a little bit differently here. So we have to have a way for us to actually choose which one of these options we're going to use. So we're going to go back up here and create another enum here. So we're going to create public enum. And remember, this is just a way of naming things, basically. Hey, Ben, how's it going? Boom! And we're going to call this enum screen effect, I guess. That seems fine. And we're going to put all our options in here. So our first option is to kill. Our second option is to bounce off, we'll call it. Our third option is to eject, and that'll be the random angle one. And our fourth option will be an explosion. So this way we have a way to tell the system what exactly it is that we want to do here. And we could just have those as developer options, or you know, maybe if they're all good, we could just have it randomly choose one to do. We could do lots of different things. Going good? Yeah, long time no talk, Ben, except we talked like, what, 20 minutes ago. We were just testing the game. Ben and I were just testing the game because there was all kinds of poopy errors that we had to figure out where they were coming from. And we found out that basically all the errors are coming from the same place. One error is just causing another error, basically. And making the game so you can't really play it very well. Okay, so this handle leave screen function, we really want to bring that enum in. So we called that enum screen effect, right? So we're going to bring in a screen effect. And based on what effect we bring in here, we're going to choose what to do. So that's going to be our argument. We may have more. So we're going to create a switch statement, because I love switch statements, as you guys probably know if you've watched me before. And it's going to be based on effect, which is this that we're bringing into this function here. Now, with a switch statement, basically all it is you're giving it a list of possibilities, and it chooses whichever possibility you gave it, and it does the code inside that block. So within this switch, we're going to have different cases for each thing here. So screen effect dot bounce will be our first case. We'll break out of that. Then we'll have our second case for screen effect dot eject. And then we'll break out of that. Basically, the break here is just so when the switch statement goes through, it goes, okay, the case is not this, but the case is this. And then it'll break out, and then anything below it will not happen. So if it picks bounce, it won't run eject after. It just breaks out of this and back up to here, basically. It does all the code inside here. So we'll have different lines of code in here. And it'll say, okay, well, the case is bounced, so it'll execute this line, this line, this line, this line. And then when it gets to here, it breaks out of the switch statement and goes down to here, if there's any code down here. And something I also like to do when I'm writing a lot of code in a switch statement is you don't actually require the curly braces, but I'll put those in. Because conceivably, we're going to be writing a few things in here. So we'll have our next case, screen effect dot explosion. And curly braces, break out of that. And then our final case will be case, screen effect dot kill. And that'll just be our simple case where we just kill the player. Break. So, now that we've created the kill ability in here, we're going to come back over here to where we said if the mechanic options are .bumper stars isn't turned on, kill the player. And instead of doing that, we're going to pull out that death function from there, and we're going to say if mechanic options .bumper stars is active, then run our function handle leave screen, but we're going to pass in screen effect dot kill. So if bumper stars is turned off, then it'll still run our handle leave screen function, but it will run its kill version, so that it'll just kill the player. We're going to get rid of this stuff because it's old and it looks messy. And now you can see that we actually need to pass in something here. So if mechanic options .bumper stars is turned off, then we're killing the player. But if it's turned on, we need to somehow decide what effect we're going to play on the player. So I think for now, like we were talking about, we could just do it randomly. So the way we're going to do that is we're going to pick a random number. Whoops. Do I need math for this? No, I guess not. I forget how to do this. How do I get a random number again? I thought it was random.range. I probably do need math or something like that, though. Oh my god, look at all the using statements here. Crap, now we have to get back to where we were. Okay, we're right here. So it is random.range. Oh shit, you need Unity Engine. Isn't that already included though in the using statements? Why wouldn't it be? Yeah, it already is. not rotation. So we want a random number between 1 and... Let's see. So our enum has 4 things. A random number between 1 and 3 because the first is always 0, and we don't want to use kill here like we were doing before. And we need to cast this to our enum. And they're also probably going to need to be ints. I'm not sure if I can do it this way. Yeah, we don't need it, I guess. Wait, but isn't there a different floor and ceiling? It's inclusive if it's ints, and it's exclusive if it's float. Wait, the minimum is inclusive and the max is exclusive. So we need to actually make the max 4 then to give us a number between 1 and 3. And cast it to screen effect, and that should work fine, I believe. Okay. Restoring Google APIs. My God. I hope you guys can't hear that. The friggin' washing machine is going off so bad beside me. It's like... I think it's like exploding. Oh my God. It's rumbling the entire house. What the fuck? Oh, I'm gonna sync the new changes. Hey Ben, if you're still here, I can't get loading from a track to work again. I don't know why, because it was just working. You can't hear it? Okay, good. I do have like a noise canceling thing on my microphone, so it's very loud in my ear right now. It's rocket rumbling the whole house. Yes, that's right. Oh my God, it's getting louder. I gotta post this to the Discord. Beautiful artwork. What the hell, Unity? Come on. Okay, anyway. So basically we want to do something similar to what we did in like our handle item hit functions and stuff here. You can see I also made enums here. And I'm checking what's killing the player. So like for the projectile, then we're running the damage player function based on the data stuff that I was showing you guys earlier. Like you have the data collection that gives you all the damage number and the sound effect that it's going to play and the visual effect that it's going to play. So we want to create some stuff like that. So for the screen kill effect, so we're going to go ahead and do that before we continue here in our function. So we're going to create some new scripts here, and I show you guys how to do a scriptable object because I've never done that before on stream. Once Unity loads. I was trying to get latest to see if I could get it to work. Anyway, so we can put our comments in here. So if kill is the case, we're going to kill the player. If bounce is the case, we're going to blow the player back on screen. If eject is the case, we're going to choose a random angle and blow them back on screen. And if the explosion is the case, then we're going to cause an explosion at the point where they hit the end screen. And we can actually make this separate from booping them too. So like if we wanted to maybe have them still die when they went off screen, but it causes an explosion wherever they exited the screen, we could do that too. So we could just make it generic. by just having an explosion function that runs separately. So we're going to make some nested functions here. So one of them is going to be void explosion. And we'll keep that nested because there's probably other functions called explosion. We're going to make one for bouncing the player back on screen. So we'll just call it bounce. And let's see, what else are we going to need? So we can use the bounce for the first and second enum case. So like we can pass in like a vector3 direction that we want this function to bounce the player back on screen, and we'll bounce them based on that. We'll do like apply a force based on the given direction. Man, that washing machine noise is driving me insane right now. I'm having such a hard time thinking. God damn it. So sorry, I'm saying a lot because of it. So we can then use this for both of these here. So like for bounce, we'll just pass that one out, or we'll just run that function. And we'll just give it the direction, which is the same as its collision. So when it hits the collision on the screen, it'll bounce them forward. And we're just going to pass in vector3 dots. Well, actually, we could pass in vector3 forward and do it locally, I guess. That's also a possibility. But we'll just pass that in now so it doesn't give me an error and I can work it in later. But for this one, we can also use that same function. And we can pass in a random vector. Or a random direction. But we were going to want it within a certain range, of course, but we can find that. And then what we can do... Oh shit, I used the wrong comment type. And then what we can do is, I guess we'll pass in vector 0 here too. And then what we can do for the explosion one is we can have a check to see if we want it to kill the player or bounce them back on screen. So we can have the explosion function run here, and then we can have a check to see, like, if kill the player, then run death, and if not kill the player, then run bounce. So we can just kind of use them modularly here for depending on whatever we want. Which is the same as what I did up here, right? So I have like a damage player function, I have an item boop function. Actually, I'll show it to you in the other one here because it's more apparent here. Oh wait, no, that was the item one. Yeah, so we have like we have functions like I have an aftershock function that adds a second force to the player. So if you want to use like collision contacts.normal to blow the player in the direction that they hit, or the opposite direction from where they hit something, but you also want to like blow them upwards at the same time, then I had like an aftershock function, or I created a stall function that just stalls the player's momentum and makes them have to restart accelerating, and it takes in an amount of time that it stalls them for. And I have a spin out function, and those are all just separate functions that I wrote down here. Like you can see item boops here, stall is here, spin out is here, aftershock. And then I could kind of distribute them how I felt. So, for example, I want the homing projectile to spin out the player and cause them to stall. I also want it to damage the player, and I want it to boop the player. But I might not want the shockwave to do all those things. I want it to damage, do the item boop, but then I want it to have an aftershock because it shoots the players straight up. And I wanted that to also stall the player. But for the bomb, I didn't want that to stall the player at all. So I use the damage player and the item boop and then have just an aftershock for the bomb so that it sends them flying in the opposite direction that they hit the object, but also sends them flying upwards, so more like an explosion, basically. You love the drawings? Thank you, Alex. So basically, we're just trying to create a modular system like this, and then what you can do even beyond this later is you can create bools for all this so that like your artists or whatever can come into your code and be like, oh, well, maybe I want, or you could even create these as separate scripts, but I don't really like doing that very much. They could like come in and toggle what they want each object to do and then pass in the data. But we didn't go quite that far. I just created the default data script, which houses all of the datas for each item, and it's a scriptable object. That's what we're going to do right now. So I will show you exactly how I did that anyway. Let me just move this over. So let's go back to what we were working on here. So we got our handle leave screen. We got our little functions started here. And we can get another one. Did you just play a yeet? Oh god, it wasn't as loud as I was expecting. I was expecting the one like last time, like, and his name was John Cena! Dun, 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 dun. It's so bad. That thing blew my eardrums off last time. So, hopefully Unity's done being stupid over here. Oh, it's totally not, because I saved something in the editor, or in Visual Studio. So we want to create some new scripts here. We want to create a scriptable object. So I have my bumper stars mode scripts here, and I've got like all the item scripts in here, and I've got all the obstacle related scripts in here. And so we want to create a new folder, and we'll call this one screen. We'll just call it screen components. And I mean, all the stuff that I'm doing today may kind of end up being superfluous, but because we may just choose to have it so that the screen just kills the player. But I don't know. I thought it would be fun to test this stuff, and it's kind of along the lines of what I was doing before. And I looked into fixing the draft, but it's not going to be as exciting as I was thinking for a stream, and I can't really tutorialize it very well because it's already been created. So that's what I decided to do instead. So we're going to create a new script, and this is going to be our scriptable object. So we're going to call it screen data. Actually, I guess we should call it kill screen. We should call everything kill screen, not just screen. So delete that, because we want to know that it's specifically for the kill screen. So we'll call it kill screen. Oh, don't do that to me. Okay. Kill screen data. Come on, Unity. Come on. Woo, woo. Okay, so this is going to be our little class that holds all the data that we may need for our kill screen. And then we're going to create another script, and this is going to be called kill screen default data. And this is going to be our scriptable object that stores our default data for the kill screen. It'll basically just store a copy of this script here. And this is if we want to make different data types for this type of thing. So this is in case we want to make like kill screens on the top and bottom, or the top and sides as well as the bottom. So, you know, for this we're only going to have one set of data. So mono behavior is what we use in Unity to denote that a script, to give it the functionality that it can be attached to an object, but we don't need that for this. This is just to hold our data here. So we're gonna make some stuff here. We're gonna have a float force. My God, learn how to spell, Mark. And we're gonna set defaults for all these. So this is how much force the screen is gonna exert, depending on what type of thing we're using here. So we're gonna make it a default of 100 because that's usually a pretty good default. And we're gonna have float damage. And we're going to make that a default of 1. Or we're not going to make that a float, actually. Float the decimal number. We're going to make it an int. And it's just going to do 1 damage. Because our characters only have 1 HP. Not enough sounds to go around. I want the John Cena sound. That's what I want. And what else are we going to need here? So, let's see. What do we add to my other ones here? Right, bumper items default data. So this is what we're creating here, a scriptable object. Oh, I'm going to copy this because I can never remember exactly the syntax for this. Okay, I got it copied anyway. We're going to go to the definition of bumper item data and see what we added. So for bumper item data, we had the enum, right? We need the enum that we created. So the enum that we created was called screen effect, right? And we're going to set that, the default of that. We're going to set the default to just the first one there, I guess, bounce. And let's see, what else did we have in here? We had an insta-kill tag. We don't need that. Or a bool for insta-kill. And then we had stuff for the animations. Right, so we're probably going to want that too. We may not need that because it may be the same for everyone, but we could put it in just to be safe. So this is for the animation system. We have enums to say what kind of item reaction we want. And the base one is just going to probably be... whoops. Base one is probably just going to be... let's see, what should we use here? I think probably the check for this guy. And item reaction as well. Oh, and I forgot to make all my stuff public. And, you know, later on, we can make this simpler by having the parts about these scripts that are the same, which is basically this stuff down here. We could just have this script inherent from a simpler version of this script. But we're not going to worry about that right now because that's just beyond the scope of what I'm talking about here. That's something that I would do off stream. So right now we're just setting it up, so we'll just keep it all the same because we may want different data in here. We'll see as we kind of go along. So we're going to set a default for that. And like I said, this is all just for the animation system here. So basically we're telling the animation system what kind of item we have and what kind of reaction we want from that item type. And that will get our hash. That'll get our string for the animation, which we have saved in a hash table. And we want an audio clip and FX. So we'll just call this the same because, like I said, we'll probably, at a later time, I will probably amalgamate these two scripts into one. So basically what I'll do is I'll see, okay, this stuff's the same, damage, everything's the same so far, but we have a different enum. So we could just have a script called bumper stars data, and both of these scripts could inherit from them. Like this script could inherit from bumper item data. And then it would get all this stuff. We wouldn't need to have it. See how it's saying, oh, this already exists. Are you sure you want to overwrite it or whatever? But like I said, we're just trying to keep the shit simple right now, so we're not going to do that. Yeah, so... And then what we're going to do is we're going to go and open our kill screen default data that we created here, and we're going to create a scriptable object to store that data and make it easily accessible for, you know, anybody on our team, anybody that's not a coder, or coders as well. It doesn't really matter. So for right now, we're going to have 4 different types. So we're going to say kill screen data, and we're going to name everything. So the first one is going to be bounce. Hi, Archer. What are you up to? And we want to define some of the data right here. So normally you can just create it like this, and it'll show up, and you can define that data in the inspector. But we want to actually define some of this data before you actually create the scriptable object here. Oh, and also we're going to need to change this mono behavior tag here to scriptable object. And then we're going to need to put that line that I copied at the top. Oh shit, I don't have a cut. No, don't do that, Archer. That's loud. We're going to copy that line that I had because I can never freaking remember it. This stupid line to give it a menu spot. So we're going to make... Basically what we're telling it to do here is we're saying create a menu item in Unity. And what's the file name going to be? Well, the file name is just going to be the same as our thing here. So it's just going to be kill screen default data as the file name. And Then we need a spot where it's going to be in the menu, so it'll be under scriptable objects in kill screen default data, and the order doesn't really matter. We'll just set it to whatever. The last thing was 6, so we'll set it to 7. And they'll all just appear in whatever order. Like, you can just set them all to 1, and they'll all just appear in whatever order the editor loads those scripts in. Oh shit, it's Bob Ross mode time. Oh my god. And since... Okay. Welcome, everybody, and welcome to The Joy of Programming with Fluffy. I'm your host. Thank you very much for joining us for another series of The Joy of Programming shows here on the Public Broadcasting Channel. It's great to have so many fans out there that are requesting us to bring... we're on the 32nd season here of The Joy of Programming. And here, instead of just calling this and calling it a day, we want to set some of these, we want to define some of the parts of this variable right away. So we're going to say kill screen bounce is equal to new kill screen data. And then we're going to use our curly braces here. But we need to end the line with a semicolon, whatever that's called. And then we're going to set some of our data in here. So what was our data again? We're going to bring this over here. And we're going to see what our data is. Okay, so we got a screen effect. Archer. So we want to set that different for each one of our entries here. So we're going to say effect is equal to... Oh, I need to make these... Oh, silly me. I made a little happy accident here. We don't make mistakes, we just make happy accidents. I'm going to need to make this public so that I can access it over here. And we're going to need to make this public. And we're going to need to make this public too. We're just going to public the devil out of it. And we're also going to make this serializable because we forgot to do that because we're stupid. And it's just going to be system.serializable. And that way, this will show up on our scriptable object when we look at it in the inspector. And so we're going to set effect equal to screen effect dot bounce. There we go. And now when we create that scriptable object, we'll already have this entry on it with squeak. Oh, and we forgot. We're not going to use a semicolon there. We would use a normal colon when we want to enter in some new stuff. So maybe we're going to set a default force for this. So we're going to say force is equal to 50. Nope, that's not enough. We're going to say 150, so it bounces you right back on screen. Oh, sorry, Archer. Did you elbow your face on my arm? We just had a happy little accident. Here with Archer. Fluffy Ross. Oh my god, why are you poking me in the ear? Boy! You giving me a dry willy? Oh my goodness. We're just gonna beat the devil out of him. And maybe we want to set a unique damage. I'm gonna say damage is equal to 2. And my God, look at us. We're using semicolons because we've been writing code. We've been writing code for 7 years, and we're too used to putting semicolons in. God damn it. Anyway, the way that this is set up is a little different. So basically, what I'm doing here is I'm just declaring a copy of this class, but instead of leaving it blank like I normally would, I'm setting some of this stuff in code so that whenever you make a new copy of the scriptable object, this data will already be in here. And you won't have to set it yourself, because that's just a pain in the ass. Now, I could make this a singleton, too, but generally speaking, for data structure things like this, like for all the player stats and stuff, I made them as scriptable objects, and I use a ton of singleton. I made my own singleton implementation for this game, so that you can just call it and create anything as a singleton, and I use a ton of singletons in this game to control a lot of different things. But for this type of data stuff, I just like to use scriptable objects, and now there's not a lot of difference really. You could create a static class, you could create a singleton, you could create a scriptable object. I mean, they're all functionally pretty similar, but what I like about doing it with a scriptable object is it just makes it easy for anybody to just open that object and edit it right in the inspector. And of course you could do that with a singleton too, but then you have to actually load a scene in the game in order to do that. And there's also other benefits to scriptable object stuff as well. Like you can set specific things as serializable, and that'll mean that like every time the object loads, or you can set certain things as non-serializable, sorry, so that they're always the same. So like if you wanted this force to be the same for every copy of this, or if you wanted this bounce to be the same or whatever, you could actually just set this to non-serialized. Then you wouldn't be able to edit it in the inspector, but all that data would save. Yep, Archer. Archer is gabbing in my ear. Anyway, so we want to create an entry like this for everything. So, nope, that's not what we want. Kill screen data. What were our other ones here? Eject was one of them, right? Oh shit, I named it wrong? I named it Kill Skeen. Kill Skeen data. And we're just gonna do the same thing. New kill scheme data, and we're gonna define it. So effect is equal to screen effect dot eject, and like I said, you know, a lot of this may be over the top or superfluous, but it makes it very easy to expand upon later. Who's Screen and why are you killing them? Or who's Skeen and why are you killing them? Because I hate Skeen, he's an asshole. He must die.
Okay.
Sorry, I'm just getting distracted by something here. Archer, shush.
What?
Shush.
I just saw that flash.
You saw what flash? Okay. We'll just copy this to make it quicker. I guess we want the eject to have the same thing, but we'll set this to 1 damage. And then we'll make one for our other two enum entries here. So we got eject, we got explosion. We actually don't need one for kill, though, because kill is just going to kill you, so... That's useless. And we want the explosion force to be, like, way higher, probably. But we'll figure that all out as we go. Anyway, so now that we have this made, I'll show you what it does. And like I said, basically the reason I made it is so that I could show you how to make a scriptable object. So now what you can do, now that I've made this create asset menu, you can go in here and you can right click in your project. You can go to create scriptable objects. You can see we have all of our scriptable objects in here. So here's our one, kill screen default data. So we're going to create a scriptable object. We're just going to leave it as the same name. And now you can see that when we open this, oh, I need to make them all public because I'm an idiot. Come on, Mark. Public. Everything needs to be public. Just make everything public all the time. That wouldn't cause any problems, right? Hey, Kara, how's it going? It's Peppa Pig. Peppa! So now you can see, here's our scriptable object. So when you click on this object in the inspector, and we store all the player stats. I created a scriptable object for the player stats for the same reason. Really, okay, static classes and singletons do have a unique difference. The reason I use singletons mostly is because they can be attached to an object in the game. Static classes are just global. They cannot be attached to an object. So singletons are very good as like object managers and stuff like that in games. Static classes are very good for places to store data that you're not going to change, or to run functions that you want to be able to run from anywhere in your game. Scriptable objects are a good place to store data that you want everybody to be able to easily access and edit. And the reason is because you don't even have to load a scene and find a specific object, blah, blah, blah. All you have to do is find this object in your project, and then you have access to all that stuff right here. You can change it while the game's running. You can change it while the game's not running. And as long as you have this referenced in your script, then you can use this data. So you can see we have all our data here that we set. We have our enum, where we can change the different type. We have our audio clip and our visual effect trigger, which is you can't just drag and drop a visual effect in here. It's an actual thing that I created a long time ago as an easy way to object pool in visual effects. But the audio clip is just a piece of audio. And we have our two things here, our item and react for animations. And you can clean this up and make it look even nicer. I'll show you. Basically, you want to come into your data script here. And you want to create like headers and stuff. So we can create a header here. We'll say we want this to be, the first thing is reaction, or no, sorry, we'll call it an effect. So effect type, or we'll call it effect data. And then down here, since this is to do with our animations, we'll create another header, and we'll call that animation data. And then down here, these are for visual effects and audio effects, so we'll make a header here, and we'll call that just FX data. And you can see that now that that's saved, we can come out in here back to our scriptable object and look at each of our entries here. And once this is loaded, you'll see the difference that makes. You can see right here. So now they have a little header, and they're kind of separated out, so you can tell that they're all something different. You can collapse each one. And you could go even a step further, like what I did for I didn't do it for scriptable objects, but I did it for a couple of my singletons, where I created this thing called the developer options panel, which is a custom editor window, where I surfaced all these values so that people could change them very easily. You could just dock this developer options panel anywhere in Unity that you want, and you can come in here and change all these game-wide settings, like the size of players, the speed, the global race speed. You can change settings to do with the barrel roll, settings to do with drafting. So I created a custom editor script to do all this. So this is like a really nice and clean way that you can go about setting this kind of stuff up. And like I said before, the main reason that you're setting this stuff up is for people that don't program, because you want, or that don't do it a lot. You want anybody that's working on your project to be able to come into your project and easily change these things. That's what you're setting up. You can hide anything else that you don't want anybody touching in your code, and they will never find it because they're not going to go looking through it. But if you want people to be able to easily access and change stuff, then you should use scriptable objects or singletons, and you could create a custom editor window. That's another option, which is basically what I did here. Yeah. You can see I have options for mechanics here. I have a thing where you can actually shut off, turn on and off the. So you can get pretty advanced with the editor window scripting. You can make it look really nice. Like I created these item buttons here where you can toggle items on and off, and that will globally toggle these items on and off throughout the whole game. And also, here's a sneak peek of all the items that we have in the game. We got the projectile, homing projectile, bomb, shield, shockwave backpack, rocket Roy, enlarger gun, and we have the gizmo grip here, which you guys voted on the name for. That's like we used to call it the lasso. We have the gravity bomb here. We have the super candy, which is kind of like the star in Mario, and we have the sword, which we actually haven't even developed yet. But yeah, there's a little sneak peek, but right now we just have these items turned on. And this is where my bumper stars mode toggle is. It's right in here. So you can just toggle the entire mode right on or off. And if you toggle it off, then everything will be a one-hit kill like it used to be in the closed beta. And we have all kinds of input settings in here too. So you can come in here and say, oh, for PC, I want to change what the button sprites look like in the game, or the Xbox ones are located in here, Sony and Nintendo ones. And you can see that I even split them up. So we have like Xbox One or Xbox Series X, PS4, PS5. And then I have a debug menu where you can turn on any of the debugs. So we can have debug logs. Like if I'm trying to debug customization, I can turn that on and it'll give me all my logs to make sure everything's working. Yeah, so basically I just created this to make it easy for anybody to change these things in the project on the fly, very simply. And all they have to have open is this base main scene with my my options script, and you can see that all that stuff is right here on my options script. Item toggles and blah blah blah, but I just made it look all nice and pretty in this developer options panel thing here. So now what we need to do that we've created this kill screen default data is we need a place to reference it, and what I usually like to do instead of referencing it in each single script is I just reference it globally, like on a game-wide scale. So you can see I have this databank script here. Now this is a we'll open up our databank script, and you can see that this is actually a singleton here that I've created using my singleton implementation. And I just reference all my scriptable objects in here. So we've got track data scriptable object. We got the player stats one. We've got a scriptable object that stores rarity types for customization items. We've got a matrix of button sprites, which is what I was just showing. And we've got data for obstacles you can run into, data for items you can run into. And now we're going to create public kill scheme default. Oh, maybe I actually called it the right thing. Yeah, I actually called it kill screen default data, not kill scheme. What's a 2-ton scriptable object look like? Also, I'm glad you're doing well, Kara. Sorry, I missed that message. Or 2-tone? 2-ton? Single ton. 2 tons. And we're just going to call this bumper screen data. And now I can just reference that anywhere without having to reference it in single scripts. And so we'll come back out into our game here, and you'll see we'll have a new entry here. Because that's the one downside of scriptable objects, is that you do have to reference them. So unlike... one of the reasons I love doing singletons and static classes so much is that you don't have to reference them anywhere. They're just global. They exist everywhere. And you can just call them. Singletons have to be on a game object, so that game object has to be loaded in. And the way that our game works, I divided it into many scenes that load in on top of each other. So you have to check and make sure that it's loaded in. But once you've done that, you can call it from anywhere. I can't.
Just for 1 minute.
Okay. I'll be right back, guys. Cool.
I just inventory. I can't do it yet. Everything's going fast.
Archer wanted to show me something in Scrap Mechanic. Hey, Ivy, how's it going? Thanks for stopping by. How's it going? Now, what the hell was I talking about? So now we've set our reference in here. So unlike a scriptable object unlike a singleton or a static class, we can't just call it by name. But we can call it like this. And I can actually show you both of those things at once. So like I said, my databank script that stores all those is a singleton. And because of the way I did my singleton implementation, we can now come in here and we can grab that data. So we can say at the beginning of our handle leave screen here, we can say that kill screen default data temp data is equal to, and we can call on that databank script because it's a singleton. So you can see we can just type the name in right here. We don't need a reference, but we do need to call it an instance. Let me move this over again. So we can call it right here, and we can bring in our bumper screen data just like that. So we don't actually have to drag and drop anything in the inspector or whatever. We can just call our databanks instance, and that's why I do that. So that I only have to drag the bumper screen data into one spot. And you could also potentially create clones of it there.
Okay.
Archer. You bum. So like if you needed to create clones of your scriptable object, which is what I do for the player data. So for the players, for example, there's like a default scriptable object, and then each player gets a instantiated clone of that. And so you could do it in here too if you needed to do that. You could just pull clones at runtime based off of the initial one, which is here. That would be mostly if you were using... So mostly what I do now is I use scriptable objects to store data. I don't actually change much of the data on them, but for the player I do. So I need to create clones so that the original scriptable object doesn't get changed, because that data always needs to be the same.
I didn't even like that one.
You didn't even like what?
The guy's coming to me.
The guy's coming to you. Are the enemies attacking you?
They're attacking me.
They're attacking you, eh?
Yeah.
Okay. So now I've lost my train of thought explaining scriptable objects to everybody. So let's see, we're doing shit in here. So now we brought in this data so we can put it to use. So the way that our screen implementation currently is basically no good, because if you come in here and look at what I originally did for this, all that we really cared about at the time in our freaking huge, or in my huge 1800 line player controller script that I wrote and then Ben eviscerated to put in all the networking stuff. So I'm sure he added it like, a couple hundred lines himself. Although the player health system script is approaching rivaling that. It's up to what, 646 lines now? Not bad. And that's like 3 streams worth of work, although I did obviously work on it outside of streams too. That's why I was hoping I could show all that stuff that I had done to you guys, but I can't really show it very easily because I can't use my test items because loading from a track is busted. So, now where is it? Here it is. In our update function. So basically my current implementation of this is no good because this doesn't give us any collision data or anything, because all we cared about was if the player falls off screen, kill the player. That's all we needed at the time. But that doesn't give us any collision data to use, and we could get away without using the collision data. And we may do that depending on what I'm thinking right now. I'm kind of formulating in my head how I want to do this. Because all we really need to do is blow the player back on screen straight. And if we're not doing that, if we're doing the eject function, then we need to blow them in a random angle back on screen, like a random cone. So we don't really need collision data to do that. So maybe we could get away with what we already have. But basically it would be more ideal to have collision data, but we didn't actually use a collision to kill the player. We just wrote a function that that checks if the player is off the camera or not, and if they are, it kills them. But maybe we should change that, because It's honestly not exactly the most ideal way of doing it, because that way, if you have a camera bug like we had when we first started introducing networking and the camera like jumps ahead for whatever reason, which happened a couple times, it just like insta-kills all the players. But we can probably get away without collision data at least. We leave it as is, I think. For now. But I could change it later. So, because of the way I created the players, their gravity and rotations and stuff are all based on the track. So I believe that all we really need to do is add a vector 3 forward to them and make sure that it's that we're adding force locally to the player, and then it should be fine. Yeah, let's just do it that way. So, because that's the easier way to do it. So, if we're bouncing them off the screen, all we want the screen to do is when they fall off the screen, we just want it to shoot them back forward, and we want it to kill a piece of their health. So we already have the damage function. So we're going to run the damage function here, damage player, and that requires us to pass in an amount of damage. Now we're going to grab that from our temp data here. So if the screen effect case is bounce, then we're going to say, actually we're going to create another, no, actually we don't. So we're going to say kill screen data, kill scree data, I mean. And we're going to call it dat is equal to temp data dot bounce. And that'll give us the data that we want from our scriptable object for bouncing. So now that we have that data, we can pass that in. So we're going to say we want it to do the amount of damage that we set in that in our scriptable object there. So we're going to pass in dat.damage, and that'll give us our damage. And now we need to pass in the information that we're going to need into our bounce function, but we're going to need something more here. We don't just need the direction, we actually also need the force that we want to exert on the player here. So we're going to make that something new. It's going to be float force. And then we're not only going to pass in our direction that we want the player to go flying, but we're also going to pass in our data.force. So that'll give us the force and make it easy for us to change in our scriptable object, and it'll always bounce them that amount. And we're going to do the same thing here, but we're going to be passing in a random vector. So we're going to create another one of these, but whoops. This is going to be for eject. And we're going to pass in dat.force again. Now for explosion, bounce is going to be optional, but we're still going to use it. And then we're not going to use it for kill. So see why I like to make it modular like this with different functions so that you can kind of change what everything does. And yes, it's probably a little overkill for what I'm doing here with the screen kill effect, but I'm just trying to explain, you know, what I would do in this type. Like, it's very not, or it's very helpful with the item, the handle item hit function, because you can have all kinds of different little functions that do different things, and then you can just kind of stack them in whatever order you want to get the exact functionality that you want out of that item. So it was super handy. You know, for Rocket Roy, we want to damage the player. We also want to play visual effects. We want to play an animation, and we want to use the aftershock, but we don't want to use the aftershock for the black hole item, maybe, although we haven't done black hole and grapple yet, and we'll get to those probably on the next stream. Oh, right. So we do have the kill option. So basically we can make a choice here, but I think what we're going to want to do is we actually are going to want to go back into our kill screen data, and we are going to want to add a bool here for whether we want to kill the player. And we're going to set it default to false because most of them won't use it. And then we're going to go back into our scriptable object here, and for the explosion, we're going to set the default of that kill player. Oh. Right. I'm an idiot. I need a comma. I'm just so used to writing semicolons. Like, writing a semicolon at the end of a line of code is trained from writing C# for 7 years. Like, it's every time it comes, I never don't do it. Anyway, so this is the only one so far, and we may write more of these. Like, we may come up with new things that we want the kill screen to do. So we just want to give it as much functionality as we possibly can here, that we can toggle on and off and change or whatever. Yes, so we need to set our dat here as well. Okay, explosion. And then what we need to do is we need to check if dat.killPlayer is true. Then we want to kill the player. And if it's not true, we want to bounce the player instead. Whoops. Either way, we're going to want to damage the player, though. So what we're going to do here is just a simple way of handling that. So we're going to create an int here, damage. Yeah, okay, I'm thinking of this right. Okay, so we're going to create an int dam, make it equal to 0 to start with. And then if we're killing the player, we're going to say damage is equal to max hit points so that it kills them. And if not, we're going to set damage is equal to dat.damage. And that way we don't have to set the damage to the max hit points in here, because we don't always necessarily know what the max hit points are. The max hit points are something that can be changed. Right now they're set to 5, but we don't want to hard code that. We never want to hard code stuff like that, because maybe down the line you decide that you want to change the amount of hit points players have to 10 instead of 5, and then all your code is messed up because you hard coded it at 5, and you have to go back through and change that also. It has to be a variable that you surface somewhere so that people can change it, and all your code has to be reliant on it as a variable, not as a hard-coded value, because you never want to have to rewrite code for something as simple as that. It just has to be based on. And then we're gonna run our death function. No, not delay death. Sorry. Or wait, no, I'm not running the death function, Mark. I'm running the damage function. So we're going to damage player based on that damage variable that we just made. And instead of doing this, I could have done it a much easier way, but I'm dumb, basically. We'll just leave it this way for now. I don't really care. And if we're killing the player, then we're gonna run damage player and damage them for max hit points. See, that's what I should have done up here. Instead of doing this stupidness, I should have just instead of creating this, because this is dumb. There's like literally no point in doing that. You just run the damage player function like this. Yeah, so that's looking good so far. And yeah, we just want to damage them for max hit points here to kill them instantly, and that's all we want to do if we have it set, if we have it tagged as kill. I don't think we want to do anything else. Now that I updated, I want to test and see if I can get my test track working or not. Bumper Stars testing ground. No. Oh, wait. Ah, shit. I messed up. So, I saved this in here, which is not a good idea. I should save it in the prefab. So my game controller is a prefab, but I can just go in here into overrides and override the version that exists in the prefab. But you should never change it in the scene if you have a prefab. I mean, some things you might. Basically, the difference is a prefab is like... So I can open this. The prefab is something that exists in your project. Let me just select the asset and show you here. So if I wanted to make, say, this databanks thing into a prefab, I could drag it into here, and it would make it a prefab. I showed you guys how to make prefabs last time, and with the test object. But anyway, this game controller that I created a long time ago is a prefab. So for something like that, where I'm adding in a new scriptable object into my databank, I want to change that in the prefab, just in case, because when we load a track by itself, we don't actually use this main scene. We just load in the game controller prefab, because this is for if you start the game from this scene. So you want to change it in your prefab, so you can open that in the prefab editor, go down to databanks, make sure it's in there. It's in there, so that's fine, and that will push the change to this version of the prefab as well that we have located in base main. But you could also do things like you want to change certain things in the prefab, but maybe certain other things you don't. Like maybe you want to add a new cube to this, maybe you want to add a new cube, or maybe you want to add a new script onto options, or you want to change some of these options values, but you don't want that to always be the case. You only want it to be in this particular scene. So it makes more sense from the test object that I created. That test object that I created right here, test item, that has all kinds of default values, and it's got our test object script on here that's set by default to projectiles. But if I wanted to drag this into a new scene and I wanted to have, like, I don't know, 3 of them, and I wanted one of these test objects to be a Rocket Roy, and I wanted the other test object to be a sword, but then maybe I wanted to change one of them to have one of these spheres to have a bigger radius. Like I wanted it to have a radius of, I don't know, 5 for the sphere collider, and then the other ones would keep with their small colliders. So you don't want to push those changes to the main prefab because then they would all have a collider like this. But maybe you want these ones by default to have a bigger collider. So in that case, you would go here and edit the collider, make it a little bit bigger, and then that would push that change to all the unchanged ones. And you can see you have overrides up here. So if they didn't get changed, then they'll have overrides. This one should have an override for the size of the sphere collider because I changed it in the scene. Anyway, that just in case you're wondering the difference between why you would want to have a prefab and why you would want to change it in the scene and maybe not somewhere else. You could also do prefab variants too, but that's just a big pain in the ass anyway. Unity brought in all this new prefab controlling stuff. I guess it was like a year and a half ago now, maybe, where you could open them in their own separate editor and stuff, which you couldn't do before, and you can do nested prefabs, which you couldn't do, which was the stupidest thing. So, like, prefabs before had to basically be a single item, and you couldn't open them in this nice little prefab editor like you can now. So now you can have these big, huge prefabs that have nested, and you can make variants of them that have different nested items in them and stuff. It's pretty sweet. Okay, anyway, let's see if my scene works. No, I don't want to save the changes now. Please work, damn you. Okay, so we gotta load the photon scene. Damn it, why is it not working? It never wants to work when I'm streaming. There's some errors right now. I really wanted to show that stuff off, but whatever. I mean, I can, but I'd have to load from the main game scene, which is a pain. What's the error on again? Oh, there's an error on the boost. Damn. 2 hours is not very long to stream. I might go a little bit later just to try to get something done here, but we got everything set up, but I still got to actually finish stuff. Okay, so where were we here? So we've got our damage in for our different things. We've got our bounce in, but we need to actually make the bounce function do something, so let's do that. So our bounce function is going to apply force based on a given direction. So it's going to be real simple. We just need the rigid body of the player, which we already have a reference to called RB. And we're going to add relative force. Now, the difference between relative force and just adding force is based on the coordinate system. So what's the easiest way I can explain this part? Let me open up a player here. So if I open up the cat here, so, oh, this is just the model, I forgot. The one with the player controller in it. Here we go, player. So, we have our player, which is its own object here, okay? Now, this is a little bit more advanced than the stuff I usually talk about on stream because I don't like getting too advanced, but I will explain it because it needs to be explained. So, we have a player parent here that I created, and then inside is my player controller with the script, the player controller script on it that I made. So, if you move this player within this player parent, you can see that the player parent stays in the same place, but the controller doesn't. The controller moves. So all the movement scripts are actually on the controller, and the player parent actually exists on a separate axis. So the general idea here is that if you want to move something forward along its forward vector, then you need to use relative force, or you need to move something along its local transform. So if you want to move it left, you know, you need it to move like this because you want the corgi to actually move himself to the left. You don't want... Basically, the thing is that once this player is moving along the track and he's over here and he's rotated like this, then the player controller is still back here with this rotation. You can see the blue axis is pointing this way. The red axis is pointing this way. The green axis is pointing up. But the player controller is on a totally different plane here now. So you don't want to add force to him based on the global position in the map. Because if you tried to add left force to him globally in the map, he would like go like on some weird angle like this. You want to add relative force dependent on his coordinate system because you want him to move left. So that's why we would use relative force instead of just adding force, because you want it to be relative to your character and his axes. So we use relative force, and we want to move him based on the direction that we brought in. And we want to move him with a certain amount of force. So we're going to do direction times force. And we're going to use a force mode. And the force mode that I typically use, because I don't use any of the built-in physics in Unity, because I think that they make the game feel like crap, basically. So I've written all my own gravity and like I do use some of the physics, but I've written all my own gravity and stuff. So I use force mode velocity change because I ignore the mass of the, for the most part, I ignore the mass. When the players go flying in the air and come back down, I've written my own gravity functions to do that, so that I can control the exact speed. And now the reason I do that is because, especially if I was creating like a platformer or something, I don't want to rely on Unity's built-in physics system to let the player go up and then fall back down, because video games don't have realistic physics don't feel good. So you want to have full control over how fast they fall and whether they fall faster at the top of their jump arc than they do at the bottom, or vice versa. Generally speaking, for me, if I'm doing a jump, I want them to go up very fast, and get slower as they're going to the top, and then at the top they start falling, but they fall slower and then they keep falling faster, which is kind of a fake real physics interaction. So I use velocity change because that's a force mode that ignores the rigid body's mass. And you know, since we're in space and stuff, like, it doesn't matter, whatever. The track does corkscrews and stuff, and if the player gets bounced up, you want them to bounce up off the track and then fall back to the track, not fall dependent on real gravity. So we're adding relative force in the direction that we feed in times the force. So if we do vector 3.up, that'll just give us like a vector. A vector is a 3-digit number, so it would be like 0, 1, 0, and each of those represents an axis, so like X, Y, and Z. And so we multiply that by the force, and that'll give us an increased push in that direction. And we're just going to pass in vector 3.forward on the bounce here. And that'll just push the player forward on his forward axis, basically. Simple, super simple. And then for eject, like I said, we're going to want to get a random angle. So we're not just going to use vector 3.forward, but we'll put that in here there for now. And on explosion, we'll set that to the same thing for now, but eventually we're not gonna use that either. This is what we might want collision data for, because if we're exploding them off the screen, we might want to know where they hit the screen. But again, I'm going to try to get away without using it.
What? What?
A cowbot? That's impossible. No, it's not true. That's impossible. You're funny, Archer. Archer says the funniest things. He's a genius. I think it's crazy with kids these days. I mean, I'm 32, so I guess I am approaching that age now where I can say shit like that. But he's 4 years old, and he can sit and play just about any video game. Like, he plays Minecraft. He plays Scrap Mechanic. and he like builds vehicles and stuff in Scrap Mechanic.
But I
He can
don't know
play
how- I don't know how much.
Minecraft Dungeons, which is basically Diablo. He can basically sit down and play any game. It's wild. He can sit down and play classic Sonic too, any side scroller. When I was 4, I didn't understand that shit. He can sit at a computer and figure out how to like move a character in first person. I just think that that's kind of crazy.
When you were my size, I was a baby, like I was you.
When I was your size, you were a baby?
Yeah.
I don't think you were born yet when I was your size.
Wait. Were you getting bigger?
Was I getting bigger?
And I was turning into a baby?
You were turning into a baby? Maybe. When you were a baby,
Ow.
I was already big.
I'm saying, goo goo gaga.
You were saying goo goo gag?
And then, that was
You were saying goo goo gaga and scrap mechani. Are you saying that your first word that you ever said was scrap mechani?
yeah. I was saying that.
You're funny.
This is a cowboy. Right now.
So basically, this is the simplest implementation of what we're doing here, right? Wise first words. Oh my god. You were just a dormant seed pod archer. Yeah. When I was archer size. You probably weren't even.
That was a crazy.
So this is the simplest implementation of what we're doing, and we're just kind of making it more advanced as we go. And like I said, I understand like that if you're a programmer, you probably look at this and say like, why are you doing this? Like you're gonna damage them here, you're gonna bounce them here. Why don't you just pass in different data? And we could do it that way, but we made this switch. We made this switch statement to handle more than just that. Like, yes, these two are similar, but maybe we want to add something else to this one later. Like maybe we want to create another function that you know, does whatever. And then, like I said, that's what I did for the choose item function. Yes, we're going to have some duplicate functionality, and that's fine, but not every case is going to use the same stuff, and, you know, it makes it nice, and so we can expand on it later. So if I decide that the screen, we want the screen to, I mean, I honestly don't know what else we'd want it to do because it's a pretty simple part of the game, but you know, whatever. If we decide that we want it to do other things, we can. And we can add all kinds of things. Wow, look at this. Nova painted this. What is it, Nova?
I don't know, it's color.
It's abstract Nova art. It's colors.
And the top one I made with pink, blue, gold, and purple.
Oh, you made it with a bunch of colors.
Yeah, I made it with those three and purple and gold.
That's cool. Here you go.
Thank you. Oh, sure.
The top one's the blood of her enemies. And one of the reasons I did it like this is because you can do some really fun stuff too. Like, you don't have to limit this to just functions. You can do stuff like I added coroutines and stuff in here that you can do, and you can call them. It's just a nice modular way of kind of sorting your code for something like this if you want something to be able to do multiple things. You know, each item has their own switch statement entry, and each item does very different things, but they also share functionality, so they just have different function calls. You know, I like sorting it like this. It's kind of a nice way. Guys, you guys are being loud. Oh yeah, I guess we were going to make it so that the eject didn't actually damage the player, maybe, for now. We could try that.
Oh, isn't that cute? Look, isn't that house so cute? And that one. It says over. It says apply.
Guys.
Bye.
Shh.
Whoa. Ooh, the same one. You want to get another book? Look at those. Oh.
Okay, so let's do our random vector here.
Too high.
So we're going to need to do a little bit of more of a calculation here instead of just passing in a direct vector. So we're going to create a temporary vector here, and we're going to call it vector3 desired desired direction, I guess, is fine enough. And we're going to do some calculations here to get our randomness. And this will give you a lot of control over it. So we can say, we can create some... So we're always going to want it to exert a forward force, but we're going to want it to also exert a random force between different angles on the x-axis, which is the left and right axis, and we're going to want it to, and those could be positive or negative because it could be left or right, and we're going to also want it to do a random on the z-axis, but we don't want it to blow you below the track. We want it to only be random from like 0 and up. So this is just an easy way to do it that give you a decent amount of control. So you could create a couple floats here. And then we'll just do it all in one, but just to show you how you could do this, a one way of doing this, you could say float y is equal to, and we'll keep it to 1 because we're still going to use our force, and we can do float x, and then we'll do float z as well. So now we're going to want our float x to be random number. So random.range, not random.range. Just like we did earlier. Ah, I see we don't need it here. And so we're going to want this to be a random number between maybe like Whoa, pulsar boom. That's a cool sound alert. That's awesome. And the oink.
Just do it! Make
Just.
your dreams come true!
Yesterday, you said tomorrow. So just do it! Don't let your dreams be dreams. Now, what? Float number between minimum is inclusive and maximum is also inclusive. Okay, that's what I thought. So If you're doing a random range of an int, then one of them is, I think the max is exclusive. But if you're doing a random range for a float, then they're both inclusive. So that means that your max number will be included in the random range, but if it was an int, it would not be included. So you need to account for that. And the Z is going to be a random range between 0 and... You're watching me on your phone? Between 0 and don't hold it too close to the mic or else it'll echo on the stream. Maybe 0.6. Love the buff. What's the buff? Does Shia LaBeouf?
No, it's over there. What's that one?
Oh, the buff, as in Shia LaBeouf, of course.
All of them are different. Oh no! Oh no! No! Okay. Wait. No, I need to do something. I need to load it. But they're gonna get out. No, they're just gonna stay in the cage. Well, we should still see? They can't do anything.
That's what 2.5 again. Let's try that.
I know, but they eat the bricks. They like to eat bricks.
And then we'll say new vector 3.
They like
So we're creating a new vector 3 here, and we'll pass in all of our stuff. So the first thing we're going to pass in is the x. Second thing is the y. And third thing is the z.
okay. Okay.
Yeah. Meow.
It's happening now.
Oh, I guess we didn't need this.
Oh, you are a poopy.
I'm a poopy butt face. Wow. What an insult. That's like the worst insult a child can say to you. A poopy butt face.
I need to do something with my fish.
And we're just going to add in a little debug log here so we can see what one's playing for testing. Oh, actually, we'll just do it up here. So we'll just debug log the effect, so it'll tell us. Now, let's see. Are they all gonna work? Max hit points. They should all work-ish, and we'll see if we can just test it. Oh wait, no, I can't test it. I need to test it in multiplayer. Let's see if I can get somebody to join a game with me then. I'll see if I can invite Ben or something if he's around. Because I can't actually test it because I have to test it in multiplayer, unfortunately. But that's okay. If we can't test it, that's alright. I don't have 2 controllers to do like a local multiplayer game, I don't think. Maybe I can get that to work, actually.
Okay. So let's do this now.
Let's do this, Archer. You bum bum. I don't know. The controllers never want to work on my computer because I'm using Windows 10 and they hate me, so, you know. Oh, look, it worked. Okay.
Oh.
Hey, this hasn't worked for a long time. This makes me very happy. Shit. No, we gotta vote for a track. Vote for Asteroid Field. Now, who knows if it's gonna work, but we'll see. Oh, okay, let's see.
Oh, did it work? No?
I believe it did work, Archer.
Yay!
Yeah, the dog just got bounced off the screen according to my debug log. Now let's see. Let's see what happens to Mr. Bird. Oh, he got bounced as well. Oh, he just got... Oh, he was out of health, I guess. He just got exploded. Exploded is not a bad word. Wow, why is the item roulette going forever? What the fuck's happening? Pick an item already, goddammit. Oh my god. Guys. Hey, the draft works. It just takes way too long to build up. There, he just got bounced back on the screen. Wait, I need to clear the log. Yeah, that's what we all want to hear. We want to hear that thing going off forever. Bounced. What happened that time? What happened? Did he just die because he was out of health? That's possible. Maybe I should just set all their damages to 0 so that we can actually test properly, but... Explosion is killing him for some reason, probably because I... Oh, wait, because I ticked it to automatically kill him, I forgot. It doesn't blow him back on screen anyway, so... Explosion again. Ah, keeps getting explosion. I'm winning? Yeah, I love that he's getting bounced back on screen. So at least that basic one's working. And so are my rock sounds. Archer's just copying everything I say right now. I don't know, I think it might be pretty good. We're gonna have to test around with it, but... It needs a little force to bounce them back on screen a little further. And I never set it to play the visual effect and stuff yet, or the sound effects, so we need to do that too, but... My god, the never-ending item roulette is so ridiculous. Oh, he just got ejected that time. He went, like, flying off the top of the screen. Oh, God. Yeah, he just went flying like crazy. My angle calculations are off because I'm stupid.
Oh, what did you say? What did you say about?
I just realized that I calculated the angles using 0.5, so he's probably going flying like... Oh god, why did I do that? Anyway, yeah, we got it working pretty good. We got the beginnings of it. Okay, that's enough copying, boy. Nope, I'm not.
Okay.
Marky, stop copying.
Stop copying.
I said stop copying.
I said stop copying.
Stop copying me! Alright guys, that's going to do it for me for today, I believe. I've been streaming for, yeah, a little over 2 hours here. Yeah, I know it was kind of uneventful compared to my last couple of streams, but I was kind of struggling to find something at this exact time to work on that I could easily explain, so the screen kill thing was the easiest thing I could kind of tackle. Yeah, but next week we can work on some more fun stuff. I think next week, instead of working on that, we'll continue working on the health system, and I'll do some of the boring stuff that I have planned, like fixing the draft and stuff like that during the week. But I think next time we can work on some of this stuff. So we need to create unique item interactions for the black hole and the grapple hook and the shield as well. So we can definitely work on that stuff next week, I think. And we'll be creating some new functions for those instead of just using the ones that we have. And I wanted to finish off this steal item function and stuff. So yeah, we can work on that stuff next week. Ideally, because that stuff is kind of on the back burner right now as far as the open beta is concerned. So that would be a good thing to do on stream for fun and show you guys. Once I can get that scene back up and running so I can actually test items here. Yeah, so hopefully it was a little bit insightful. I always try to keep the streams as basic knowledge as possible so that you guys can understand what I'm doing. Hopefully it's not too bad. But I appreciate you guys sticking around and watching. Thank you very much, and I hope you guys have a great rest of your day. And yeah, if you guys don't know me or Pixelnuts or Bumper Stars, definitely, if you guys are interested in the game, you can check it out on Steam. Or sorry, it's not called Bumper Stars, Mark. It's called Rocket Rumble. If you guys are interested at all in the game or us as a company, you can join our Discord. You can find that information below. You can join... Or you can wish list the game on Steam. You can just search it Rocket Rumble, and soon we'll be opening up open beta invites. So if you click follow on the game on the Steam page, I'll show you guys the Steam page right now. But if I can get the store page to load. So if you guys wish list it, but also if you click the follow button on the game, you will get updates about events that we're doing, like this stream, or when we do our gameplay test streams, and you'll also get updates when our open beta signups go live. You can see these are some of our recent event announcements here, like Alex's art design thing. And here's me streaming right here, talking to you guys. I'm also streaming on Steam. So you can actually watch it there if you want to. But yeah, anyway. This is where you can check out the game. If you want to talk to us or check out us as a company, you can follow us on Discord. If you want to see me streaming, you know, where I actually play games and stuff like that, you can check me out on my Twitch channel, which is twitch.tv/markgamedev. You can see it along the bottom of the screen there. And yeah, just thank you guys very much for watching. Hope to talk to some of you guys soon in Discord and stuff like that. And I hope you guys have a great rest of your day, and don't forget to tune in tomorrow for our gameplay stream, which I believe will be at 3 o'clock, and that'll be all of us as a team testing out all the new Bumper Stars changes, as well as other things, testing out our networking and party mechanics and all that stuff. So yeah, come and check out that if you want to enjoy watching us test our game and trying to break it as well as we can. Anyway, guys, thanks for watching, and have a good one. Talk to you guys soon.
Mommy, what did you mean? What did you mean?